We are going to be covering a really tough unit, tough lesson. So hopefully you're following along. I'll try to attach a blank version of the examples we're going to do so you can follow along. So 53.A is a review of unit conversions, so converting like inches to feet or feet to miles. Page 353, they have listed all the conversion facts, like how many feet are in a mile and how many seconds are in an hour, how many kilometers. All that is on page 353, so if you want to put a post-it on that page, it'd be better than me rewriting it a million times. So example number 1. So we are going to convert the following. We are going to convert in part A 40 miles per hour to meters per second. And it doesn't matter what order you do things in, but just that you're canceling and setting everything up correctly. So 40 miles per 1 hour. So that is how this should be set up. Okay, and now I need to convert this to meters and seconds. It doesn't matter which one you deal with first. I know that there are 3,600 seconds. Whoops. I set that up backwards. I need the hour to cancel, so that should go on top. 1 hour has 3,600 seconds, and I'm getting that because there are 60 seconds in a minute times 60 minutes in an hour. So notice hour over hour is gone. So I have seconds. So I've done that part. Now I need to convert miles to meters. So there are a couple ways to get there, but I am going to get down to inches and then convert that to centimeters and then that to meters. So I know that there are 5,280 feet per 1 mile. So that's gone. I know that there is 1 foot is 12 inches. So now that's gone. I know that according to my book, there are 2.54 centimeters in 1 inch. So now that's gone. And last, there are 100 centimeters per 1 meter. So I've now done the meters. So I want you to notice what we have left. The only thing I have left that I haven't crossed out is meters per second. So I know I'm done converting. Now I have to do the multiplying and dividing. So I am left with, sorry, this is for this. Okay, so on top I have 40 times, I don't need to write the ones, right? 5,280 times 12 times 2.54. And on the bottom, I've got 3,600 times 100. So that is what I'm going to enter. I get 6,437,376 divided by 360,000, and I'm left with 17.88 meters per second. Okay, so that is review, and we're going to be doing this more today, but that is review on how to convert. Now these are really long, and they are going to be in your homework as well. So part B, and this is to prepare us for 53.B. So in part B, we're going to convert 30 centimeters per second to kilometers per hour. Right, so I'm going to set up this part right here first. So that would be 30 centimeters per 1 second. There's an invisible 1 here. And I need to convert this to kilometers and hours. So I'm going to start with 1 second. Remember, there are 3,600 seconds in 1 hour. So I've taken care of the hour. I like to check it off. Now I need to go from centimeters to kilometers. Well, I know there are 100 centimeters per 1 meter. So that's taken care of here. And then there are 1,000. Did I set that up right? There are 30. No, I did not set that up right. Sorry about that. Now, okay, there are two ways to do this. I could go from centimeters to meters to kilometers. That would be one way to do it. Or I can go from centimeters to inches to feet to kilometers. It's really up to you guys. So I think I'm going to stick with what I was doing. So sorry, there are 100 centimeters in 1 meter. And there are 1,000 meters in 1 kilometer. And so I have, I'm going to circle what I have left. I have kilometers and hours. Everything else I've crossed out. So on the top I have 30 times 3,600. And on the bottom I have 100 times 1,000. I feel like on the top, so 30 times 3,600 gives me 108,000, and on the bottom I have 100,000. And so if I divide that, I end up with 1.08 kilometers per hour. So that is a review. Sorry, I had a little brain fart. That is a review on how to convert. Now we are going to use this to do the part that is difficult. And that is section 53.B. And it is on angular velocity. All right, so angular velocity. Let's talk about, here's my really bad drawing of a car. Okay, now there are two velocities happening. My car is moving forward, so the forward motion would be my linear velocity. Right, and linear velocity is how fast something is moving forward. Now there are two velocities taking place. The linear velocity is how fast your car is moving forward. The angular velocity is how fast your wheels are spinning. So angular velocity is the rate at which any circular, but in this example, it would be the wheels. But angular velocity is the rate at which the circular object is rotating. Another word would be revolutions. Or another way to say that is how fast the wheels are spinning. Now, the formal term is revolutions, which is what we're going to see. So I'm going to go over the two formulas we're going to use, and we'll get into specifics in a second. So linear velocity is the following formula, is your rate times angular. So this is your formula for linear velocity. Okay, and note that W represents your angular velocity. I should have put an equal sign and not parentheses. R represents your radians or your rotations, but we'll go over that in a second. Okay, your angular velocity is W equals your linear times 1 over R. And so this is my angular. All right, now this is kind of, sorry, my computer timed out, so I want to make sure I unlock my screen. All right, so here are my two formulas we're going to be using. Here's linear velocity. Here is angular velocity. And so here we go. Oh, a couple things. One revolution. Another word for revolution is rotation. Equals, if I do one full rotation, and it's a circular object, then one rotation or one revolution would be the formula of circumference, which is 2 pi r. Now, I know this is a lot, so let's jump into some examples that we are going to do together. I will attach a blank copy so that you can be doing this along with me. Now, a couple things I should note. That my angular velocity, W, has to be in radians because we're talking about a circle. And if I have no units on the top, then I know that I am in radians. And so those are a couple things to note. And then, of course, my formulas. All right, so example number 1. Wheels on a vehicle are revolving at 500 radians per second. What is the velocity of the car in kilometers per hour if the radius of the wheel is 11 inches? So let's talk about our formula. L equals W times R. Okay, R represents radius. And W is the angular velocity or the rate of revolutions. So let's set it up. Linear velocity, they have told us, is 500 radians per 1 second times my radius, which is 11 inches. Now notice that they want my answer in kilometers per hour. So I have to convert inches to kilometers and seconds to hours. So let's deal. So this is how you would set it up. Here is how you would set up. Now I have to now do my conversions. So let's start, this is just over 1. So let's start with there are 3,600 seconds. Hopefully I have room per 1 hour. So seconds is taken care of. Now I'm going to leave the radians for now. I need to do, I have hours, so check. I now need to do kilometers. So I know that there are 2.54 centimeters in 1 inch. So inches is taken care of. I know that there are 100 centimeters in 1 meter, and I know that there are 1,000 meters in 1 kilometer. So I have now taken care of everything. Notice what's left. I have kilometer per hour. So I have converted it. Okay, it's okay that it says radians. We can leave it because W has to be in radians. So I'm now going to multiply what I have left. So my linear velocity, in the top I have 500 times 11 times 3,600 times 2.54. I'm going to do all that divided by 100 times 1,000. Okay, and I get 502.92 kilometers per hour, what's left on the bottom. Okay, so that is how fast, linear velocity is how fast you're moving forward. So that is how fast this vehicle is moving forward. Very fast. All right, number 2. 425 radians per minute. Okay, that's W. That's how fast your wheels are turning. However, the wheels only have a radius, here's your radius, of 4 centimeters. So here's R. What was the velocity in miles per hour? So that is the conversion they would like to take place. So linear velocity, they want to know how far we're moving forward, and I know that because miles per hour is how fast your car is moving forward. So I have 425 radians per 1 minute times my radius of 4 centimeters. So this is my formula, right? This is W times R. Now I have to do all of the conversions. So everything else is going to be the conversions to miles per hour. Okay, so this is my formula for linear velocity. The rest is to convert it to the dimensions they'd like it in. So let's deal with centimeters. I have 1 inch per 2.54 centimeters. So I've gotten rid, if this helps, you can just put a 1 underneath. But I know that I've gotten rid of centimeters, but I need it in miles. So now I have to go, I know that there are 12 inches per 1 foot. So this is gone. I know there are 50 to 80 feet. Notice I put it on the bottom because it has to be top bottom to cancel per 1 mile. So I have now gotten the miles. So check. Now I need to convert it to hours. I have 1 minute, so I know that there are 60 minutes top, bottom per 1 hour. So on the top, I'm left with radians, and that's okay, and miles per hour. Okay, so I am left with 425 times 4, 1 times 60, divided by 2.54 times 12 times 5280. And I got, now this is going to be really small, but that makes sense because my wheel, think of this as a tiny, tiny little, you know, those little cars you buy that are like this big that you play with as a little kid. Okay, so that is why this number is going to be so small because you have such a tiny vehicle, right? So a tiny, tiny, tiny little toy car is not going to travel that fast in miles per hour. So that is why my answer, 0.634, is less than 1 mile per hour. But in an hour, it could get 2/3 of a mile. That's pretty good. All right, now I have started with linear velocity. We're now going to work backwards, okay? So a wheel rolled down the hill with a linear velocity of 120 miles per hour. What was its angular velocity in radians per second if the diameter is 90 centimeters? So let's start there. If my diameter is 90 centimeters, my radius is 45 centimeters. So remember, angular velocity, that's angular velocity. So they're asking how fast our wheel is spinning, equals, and our formula is our linear velocity times 1 over our radius. So that is linear. And I don't know why I put, oh, and that's technically, I've been writing L, but it's technically V. And I don't want that to confuse you later. But my V is linear velocity. Okay? W, and how I remember it, W stands for your wheel. V stands for velocity. So this is linear velocity. That right there is radius. So if that helps, it's all right here. So they're wanting to know what is my angular velocity. Let's see if I can fit. If my linear velocity is 120 miles per 1 hour times 1 over my radius, which is 45 centimeters. So this is my formula Now I have to do all of our conversions, and hopefully I can fit it. Otherwise, I'm going to be writing on another piece of paper. So I need to convert this to radians per second. So let's start with second. I have 3,600. Whoops. If hours is on the bottom, it needs to be on the top. So 1 hour is 3,600 seconds. So this is gone. I need to get rid of the centimeters and the miles because I'll know it's in radians once I have nothing left on the top. So I know that there are 5,280 feet per 1 mile. I know that there is 1 foot is 12 inches, so feet are gone. I now need to get inches into centimeters, so I know that there are 2.54 centimeters in 1 inch. So I'm going to talk about what I did here. The only thing I'm left with, notice there's nothing in the top. In the bottom, all I have is seconds. And so I now know I'm in radians because I converted my centimeters and inches. I got rid of all of it but time. Radians, there should be nothing left. So my angular velocity is 120, that's what's on top, times 5,280 times 12 times 2.54 divided by 45 times 3,600. So that's what I have left. So I'm left with 119.21 radians per second. So this is how fast that my wheels are spinning per second. Kind of crazy. I'm going to do 3 more with you, and then that'll complete this section. I know that's a lot, but then you can use this to complete homework. So the Formula 1 car came by at a speed of 275 kilometers per hour. It's really fast. The wheels are very large in Formula 1. The radius is 1 foot. What was their angular velocity in revolutions per minute? So they're wanting to know, okay, how fast that wheel is spinning. The last one wanted to know angular velocity as well, but this specifically wants our revolutions per minute. So how many times the wheel spins or rotates per minute. So let's remember angular velocity equals our linear velocity times 1 over r. So here we go. I have 275 kilometers per 1 hour. That's what I have so far. Times my radius. So I have, and I have radians per minute. So I have 1 over my radius, which is 1 foot. Now I need to start converting this. So this is per minute. So I know that in 1 hour, I have 60 minutes. So I've taken care of the minutes. Check. Let's get rid of our kilometers. So I know that, let's start with, I know that in 1 foot there are 12 inches. I know that I'm trying to get kilometers, inches, all that to cancel. I know that there are, in 1 inch, there are 2.54 centimeters. I know that there are 100 centimeters per 1 meter. And I know that there are 1,000 meters per 1 kilometer. And so I'm going to go over what we have left. So kilometers is gone, meters is gone, centimeters is gone, inches, feet. So notice I know that's in radians because I have no dimensions left in the top. All I have in the bottom is minutes. So my angular velocity is 275 times 1 times 100 times 1,000 all over 60 times 12 times 2.54. So that gives me, so far, I have, well, and I'm going to go ahead and add. I'm going to have to convert this. So far, I have radians per minute. And if you want, I'll go ahead and leave that. So this is radians per minute. And so far I have 275 times 100 times 1,000. I did this separately in my notes, my apologies. Divided by 60 times 12 times 2.54. Make sure you put the bottom in parentheses. So I'm left with 15,037.18 radians per 1 minute. But it asked for revolutions. So I have to convert this to revolutions. And I know that 1 revolution is 2 pi radians. And the reason I didn't put 2 pi r is I already divided it by the radius earlier. Okay, so I don't need to do the radius again. So these radians are gone, but now I have 2,393.24 revolutions per minute. So I had to convert it from radians to revolutions. So that one's pretty hard. Number 5, the wheel of a wagon has a radius of 14 inches. It's revolving at 40 revolutions per minute. How fast is the wagon moving in miles per hour? Remember, how fast, they're asking for our linear velocity. Okay, so let's start with what I have. I have to convert W must be in radians. So 40 revolutions per 1 minute has to be multiplied by 2 pi. I'm not going to do the radius over 1 revolution. Now, the reason I'm not doing my radius, we'll deal with the conversion later. So I end up with 80 pi over 1 minute. So this is in radians, and I know it's in radians because I have pi. Now I can find velocity. So velocity, I have 80 pi over 1 minute times, this is why I didn't use radius here, because now I'm going to do my radius. My radius is 14 inches, right? And I just have over an invisible 1. Now this is my formula. This is W times R. Now I have to do my conversions. They want it in miles per hour. So minutes, there are 60 minutes, right, in 1 hour. Miles, let's see here, there are 12 inches in 1 foot. So minutes are gone, inches are gone. There in 1 mile is 5,280 feet. So feet is gone. So I'm left with miles per hour. So we should have 80 pi times 14 times 60 divided by 12 times 5,280. And so make sure you put this in parentheses if you enter it all at once. So I have 3.33 miles per hour. So I'm trying to do, I looked up your homework. Each of these looks like one of the examples in your homework. So last one. Michelle's car had wheels revolving at 120 revolutions per hour. Okay, this is going to have to be converted to radians. What was the velocity of the car in centimeters per second if the wheels had a radius of 10 inches? So first thing I need to do, 120 revolutions per 1 hour. There are 2 pi radians in 1 revolution. So this cancels and I'm left with 240 pi in 1 hour radians. Okay, W, angular velocity, has to be in radians. So I now have velocity equals W times 1 over R, right? That is my, yep. So here we go. I have velocity equals 240 pi radians per 1 hour times 1 over a radius of 10 inches. Okay, now I'm using this formula because it asked me for the velocity. And so when it asks me for velocity, I'm finding velocity. I'm going to do all my conversions. So I know that, and I have to get rid, I know that 1 inch is 2.54 centimeters. Right, so I've got my centimeters. Now I need to do seconds that are 1 hour. So there goes hour. Is 3,600 seconds. And that's it, right? I got rid of, I have centimeters per second. Did I mess this up? Yes, this should just be R. Michelle. That's what happens when you're trying to go fast to get this video done. This is 10 inches over 1. This is 1 inch is 2.54 centimeters. There we go. I now have centimeters per second. I now have centimeters and seconds. Everything else has canceled. So I have 240 pi times 10 times 2.54 divided by 3,600. And I got 5.32 centimeters on top per 1 second. That is how fast the car is traveling. Whew, I know this section is hard. I will attach a blank copy for you to do this with me. You can copy. I would print this out and have it with you, and so anytime you see a homework problem from this section, you have examples to work with. So I'm going to write the homework that we're skipping at the top. So for homework 53, skip numbers 4, 5, 21, 23, 26, 27, and did I skip? I did. 20 and 30. I apologize if the 20 is out of order. Thank you.